Hello students, in this video we'll discuss the Frenet-Serret equations. For a curve r of s in arc length parameter, we have the Frenet-Serret frame, t hat, p hat, and b hat. And we already know the first Frenet-Serret equation, namely dt ds is the curvature times p hat of s. This is the first Frenet-Serret. This is Frenet-Serret number 1. And we also know the definition of torsion. The definition of torsion is negative b hat dot dp ds. Let's use the definition of torsion to find out the third Frenet-Serret equation. So the third Frenet-Serret equation uses the fact that dB ds is a number a times t hat plus a number b times p hat plus a number c times b hat, because t, p, and b play the same role as I, j, and k, so you can write any vector, namely dB ds, as a combination of t, p, and b. Now what we'll do is we'll dot both sides of this equation with b, so b dot dB ds. Well, if I do b dot t, I'll get 0. If I do b dot p, I'll get 0. If I do b dot b, I'll get 1. So this is equal to the coefficient c. Now we know that b dot b is equal to 1 since it's a unit vector. So differentiating this relationship by taking the derivative, we can claim that 2 b hat dot dB ds is equal to 0. So this c is equal to 0. So there's no, so this, of course, is twice c. So c is equal to 0. And so what we see is we see that we each have an a and a b term in this dB ds. If I dot both sides of this equation with t, I will find that that will give me an a, and p dot t is 0, so this will be a. But we can use the relationship that t dot b is equal to 0. So if we differentiate this, we'll get t hat dot dB ds, first times derivative of the second, dot derivative of the second, plus dt ds dot b hat, and it's equal to 0. But this is the curvature times p hat, and p dot b is equal to 0, so that term is 0. So we can conclude from this that t dot dB ds is equal to 0. So this a is equal to 0. A is equal to 0. So that's gone. And so finally, if we dot with p, we have that p dot dB ds is equal to the coefficient b. And so we know that p dot b is equal to 0. So if we differentiate this, we'll have dP ds dot b hat plus dB ds dot p is equal to 0. And this allows me to conclude that p dot dB ds, p dot dB ds is equal to negative dP ds dot b. And now we see that this expression over here is exactly equal to the torsion. So we have p dot dB ds is equal to the torsion. And so from this, we're able to deduce the third Frenet-Serret equation, because this over here is the negative. So we have the third Frenet-Serret equation, which says that dB ds is equal to, well, this b over here. Let's take a look. So b is dP ds, and dP ds from this formula over here is equal to the torsion. So dP ds will be, dB ds will be negative torsion p hat of s. And this gives us the third Frenet-Serret equation. So this is Frenet-Serret number 3. In the next video, we'll discuss the second Frenet-Serret equation using the same methodology. Thank you very much.